All right, Algebra 1. Let's see. Notes for, let's see. Put your name, date, and period on it. So this is Algebra 1. And this is going to be section 8.4, graphing parabolas, which we've been doing for a while, in vertex form. So we've been slowly seeing some different forms of what the equation of parabola could look like. So this one's going to be a big change from last couple. Fx equals a x minus h squared plus k. And I think we started with this form way back at the beginning. So the a value is, it scales it, makes it bigger or shorter, stretches it or shrinks it. And if it's negative, it flips it upside down. Reflection tells you if it opens up or down. The h and the k tell you where the vertex is. So h moves it left, right in the x direction. I mean, you can remember that because it's with the x. And the k is outside of it. It moves it up, down. It just moves the whole graph. It shifts it. Now, even simpler than that, it tells you, so the vertex is usually at 0, 0, the origin. So if it gets moved left or right this much and up or down this much, that should tell you the new location of the vertex. So the vertex is going to be at h comma k. So the vertex, the h and the k are going to give you the vertex. Now, you got to watch out because of this minus right here. The number you see here is the first number you think of is not going to be the right number. It's going to be the opposite of h. Okay, so whatever you see here, if it says x plus 3, then it's actually negative 3. If it says x minus 2, it's actually positive 2. The k is good. The k is just what it is. So that's the vertex. We can also easily get the axis of symmetry from this. So axis of symmetry, or AOS, or line of symmetry, it's a vertical line, so it's always x equals something, some number, and it's going to be where the h is. Okay. Now, it gets, we're going to just do a couple examples with this and make the graphs and answer a bunch of questions like the ones we've been answering. So let's do example 1. And the function we're going to graph and figure everything about is going to be fx equals 2x plus 5 squared minus 4. Now I'm going to make a graph over here. Again, doing this on graph paper is going to be a lot easier than drawing your own little graphs on your paper like I'm doing. But it's up to you. A lot quicker, easier, looks nicer. I mean, I can draw pretty straight lines, but if you're doing on graph paper, you can just draw the x and y axes in. Make sure you put arrows on the ends and label them. Okay. And you could, totally use pencil. Now I'm probably going to use a different color pen for some of the stuff to just make it stand out on my graph because I wrote it in pen originally. But if you have graph paper, you could probably just do it all in pencil, no problem. Unless you like different colors. Okay. Okay. So there's my graph ready to go. So the first thing we got to figure out, I think, we got to figure out h and k. So what you might do, just to make it look more like this, you see how there's a minus here and there's a plus here? So we might try and make it look more like that. You don't have to. You could, again, like I said, you're going to think h is 5. Here's h, here's k. But h is actually negative 5. And it'll make sense if you force it to have a negative there, then this would have to be a negative 5 to end up giving you plus 5, right? And so that makes it obvious that h is -5 and k is -4. And what is in front of the k? That does belong to it. Okay. So you got to figure that out. So from that, our vertex is hk, right? So that's going to give us -5, -4. It doesn't matter. The h comes first and the k comes second. X first, y second. The axis of symmetry or the AOS for short is just x equals -5. Now on my graph, let's go and put those things on here. -5 would be left 1, 2, 3, 4, 5, and then -4 is down 1, 2, 3, 4. So that's your vertex. Okay, and the axis symmetry goes right through it, so it's kind of hard to miss. Let me use a different. Like I said, if you have graph paper, you could just do this in pencil, but usually make it dashed and you put arrows on the ends of it. We could label it too real quick. AOS x equals -5. So vertical lines are always x equals number. We could write down the a value. The a value is 2. That's the a value, right? A value is 2, which is positive, greater than 0, which means it opens up or down. Does it open up or down? It's positive, it opens up. That's just because it's positive. The vertical, because it's 2, it's going to be a vertical stretch. It's going to stretch it by factor of 2. So it's going to stretch it. And it's going to open up, which we already said. Okay. Now, H tells you if you're going to move the graph left or right. And because it's negative, it's going to be left by an amount of -5. It's going to move the left 5. K tells you if it moves it up or down. And because K is negative, it's going to move it down. Down 4, -4. Now we do need a couple more points. This is not enough to graph a parabola. So you usually want like a couple points on both sides of the vertex. So we need more points. And usually it's easiest to do them near the vertex. So use your vertex to decide which points you want to do. And a lot of times a table is kind of helpful here. So I'm going to make a little table and plug it in to f of x. I'm going to rewrite it right here just to have it like really close to where my work is to make sure I do it correctly. So now I'm going to pick here. Usually you want smaller numbers. Positive numbers are better. Smaller negative numbers. So, I mean, I could do -6, but I could do -4. I think I'd rather do -4. So we're going to plug -4 in. And we're going to plug it in for x. And so that's going to be +1 squared. You got to do order of operations, PEMDAS, parentheses, then exponents. 1 squared is 1, so that's going to be 2 times 1 is 2 minus 4 is -2. So -4, -2, that's your next point. And then we like to take advantage of the fact that parabolas are symmetric, and that means the left side and the right side look the same, so we can do a mirror point over on the other side real quick without having to calculate it. Let's do one more. We can do -3. The further you get away from the vertex, you're like, oh, I'm going to do 0. You get bigger values, which might be off of your graph. So let's do -3. -3 plus 5 squared minus 4. I'm just showing my work here. -3 plus 5 is 2. Squared is 4. 2 times 4 is 8. Minus 4 is 4. So -3, 4 is going to be up here. And we can do a mirror image on the other side. 2A this side, 2A that side. So I think that's pretty good. Got a lot of points here. Okay. There's a couple more questions we're going to answer. Let's see, domain. We've been answering that a lot of times. So domain's all the x values, and it's all real numbers. You can plug any x in, and it'll give you an answer. The shortcut for writing all real numbers is like this capital R with like an extra line on it. The range is all the y values, which is usually not all reals for these graphs. So it's y is, this is the bottom down here. This is the minimum, right? So that's your smallest y value, and then everything above it works. So y is greater than or equal to -4. And then another question we've been answering is the vertex a minimum or maximum? And it is a minimum. Okay, so let's do another example. I feel like I think I have to do it on a separate piece of paper. I'm running out of room. So I'm just going to do it on a piece of paper. And we have one more example too that's kind of shorter after it too. So it's totally fit. Okay, so example 2. We're going to do the same thing. But this one is going to be fx equals -1/2 x minus 3 squared plus 1. So right away, you guys should be starting to recognize things. Oh, well, the negative in front, that's the a value, is going to make it go upside down. Reflect it. The 1/2 is going to shrink it. This is your h, this is your k. So here's your h, here's your k, here's your a. So the vertex is going to be at 3, 1, because remember, it's x minus h. So the number you see there, it's the opposite of the -3, but this is going to be the same. We are going to do a graph, so I'm going to make a place for me to graph it. Okay. So, got my graph ready. So the vertex is 3, 1. So we can put that on here. Right 3, up 1. That's our vertex. And the axis of symmetry is at x equals 3. So we could draw that. Usually, because it's right on top of one of these lines, I like to use a different color. If it's a regular graph paper, I could just use pencil. But we make it dashed and usually kind of light. I can't really do that here. So that, because it's not really part of the graph, it's just, it kind of shows an important aspect of the graph. Okay, so then the a value is -1/2. And so it's negative, it's less than 0. So does it opens up or down? Well, if it's negative, it's going to open down. Okay, we call that a reflection. So reflection. The fact that it's 1/2 is going to make it a vertical shrink by a factor of 1/2. It's going to make everything shorter than normal. And so since the h is going to be left or right, we already kind of talked about this, left or right. Because the h is positive, it moves it to the right, right? Because h equals +3, not -3. Remember, it's the opposite. Because you have to, well, what would I put here to get -h? Well, you put a 3 there. The k moves the graph up or down. Just moves the whole thing. And since it is positive, it's going to go up 1. And then we need a couple more points. So we're going to make a little table here. Now I want to pick points near the vertex. You could try and be like fancy and pick some points, because this 1/2 here means that we might get some fractions in answers, which is a little more annoying to graph. It's not too bad. But if you pick a number in here for x that you know when it gets squared is some number that's like 2, 4, 6, 8, and then you divide by 2, you get a nice answer, then you can do that. But I'm just gonna do 2 and then 1. So if I plug 2 in here, this is not going to give me a pretty answer. So it's going to be -1 squared. -1 squared is +1 times -1/2 is -1/2. So the negatives don't cancel here, because there's right here you got to do parentheses exponents. -1 squared is +1, and there's still a negative. So it's going to be 1/2. So if I go to 1/2, it's going to be right here, like 1/2 of a square, and then there's a mirror point on the other side. 1's going to work out a little nicer, a little prettier. And you could, if you're thoughtful enough, pick points that come out nicer. So if you plug 1 in, 1 minus 3 is -2. Squared is going to give you 4, right? And 1/2 of 4 is 2. It's going to be -2 plus 1 equals -1. So it kind of came out nice. If you plug 0 in, it wouldn't be pretty. If you plugged in -1, it'd kind of work out a little nicer, like give you nice answers. But this is enough. Also, if you plug in 0, it gives you your y-intercept, which we don't see as easily in these equations like we did on some of the other sections. So that's our parabola. We want to state the domain. So the domain is all real numbers for x. The range is the y value. So this is a max right here, right? That's a high point because everything's below it. So the y values are going to be below or equal to that y value there. So y is less than or equal to 1 is your range. Minimum or maximum. It's maximum. The vertex is maximum. So that's what we're going to be doing. I got one more example for you. That should be a little quicker. We're not going to graph it. So example 3. So this is kind of like the same idea, but going backwards. So they're not going to give you an equation. Your job is to write the equation in vertex form. So they don't give you the equation. They don't give. Okay, so here they're going to tell us that the vertex is at 1, 2 and passes through, the graph passes through the point 3, 10. Okay. Now, it passes through infinite number of points. So they can give you any point and you do the work the same way here. The vertex is special. That's your HK, right? This point is just like any other point on your graph, like the ones we've got on the table. So that's just the XY pair. And that's going to help us. Now, what we're trying to do is we're trying to write the equation like this. And this might be helpful to write it down. Y equals A, x minus h squared plus k. This is our goal. We have the h and the k. That's easy. I'm going to go and actually rewrite it right now. and plug the H in and the K in. And we're almost done. All we need is the A value. This is not the A value. None of this is the A value, but we could use, if we have H and K in there, and then we have any XY pair, we could plug those in, and then the only thing left that we don't know is A, and we could find A. We could solve for A. So that's what I'm going to do. I'm going to plug 10 in for Y, 3 in for X. Okay, and then I'm going to simplify it. 3 minus 1 is 2 squared. Parentheses, exponents would be next. 2 squared is 4, and that's multiplication right there. And then we could start to get A by itself. Like we would subtract 2 from both sides. And A times 4 is 4A. Divide both sides by 4. And A equals 2. That's not our answer. So we're going to write our final answer. Y equals 2x minus 1 squared plus 2. So we got everything. So the hardest part was figuring out the A. Your classwork, monitoring progress, is going to be in section 8.4 in your book, page 442, problems 1 through 8 all. They're at the bottom of each page. The Student Dynamic ebook is really helpful because next to each one, they have a little blue arrow button. And if you play it, it will give you it'll show you a video showing you how to do the problem. So try it out.